My name is Michael Tayler, and I'm a staff scientist at the Institute of Photonic Sciences in Barcelona, in Spain. So we are an atomic, molecular, optical, and nuclear physics group, which means that we study magnetic resonance perhaps in its broadest context, not just, for example, in applications in chemistry. We study EPR, optical detection of spin states, and this is applied to a variety of systems from atomic vapors to solids to liquids, and the methodology itself. Magnetic resonance is an extremely versatile technique. It allows you to study not just samples in small tubes in the chemistry lab, but all the way up to large systems, whether it's rocks in the ground or even in space. One can apply magnetic resonance techniques. And there are many things, of course, that magnetic resonance is often the only technique. If you want to study phenomena in the brain, or if you want to image the lungs, there are sometimes no other techniques to match. And if you look at it from a physics point of view, you look at the spins and the spins interacting with magnetic field, there are enormous number of degrees of freedom in the system that can be used to gain information and can be exploited as well to make the system do things that you want. So in the Twitter conference, we presented, if you like, a side activity from our research, which was a miniature NMR spectrometer, which was based on existing open source electronic tools. It was called NMRduino, and it's something that we hope to release very shortly. And it's going to be a credit card sized spectrometer, but we wanted to release a little electronics board that you would plug into your laptop and you could start doing magnetic resonance experiments. It's already part of a number of papers that we've published on our research, but we wanted to get this out into the community as an open source project for people to use. So far, we've used the NMRduino for a variety of magnetic resonance experiments, from hyperpolarization, which is a very interesting and emerging area of magnetic resonance these days, to pulse design, to magnetic resonance in the Earth's field. And many of these concepts, these types of experiment, can also be applied in teaching. And that was one of the things that really excited us about this project, because we thought, wouldn't it be great if you were a student and you were learning magnetic resonance with a textbook, but you also had a companion instrument that you could test out whatever you learned in the textbook. That's a concept that I wish that I had when I was a student, and maybe it's something that students will have in the future, and it will be a tool that attracts more people into this field. As I mentioned, the NMRduino is capable of being spread to a much larger audience than existing commercial NMR hardware. We hope that it gets out beyond the research lab and beyond chemistry departments, and there emerge new applications for magnetic resonance. As I mentioned, our general theme is to study atomic, molecular, nuclear, and optical systems. We find that at the interface of all of these fields, either taking, for example, atomic systems and nuclear systems, or optical and nuclear systems, we can start to develop new methods and techniques that have not been available before to broaden the scope of where magnetic resonance is applied. And one of the directions that we're going in the moment is optical detection of MRI and using low magnetic fields. And the NMRduino is actually part of that. We can use it to control the magnetic resonance imaging.